We are the RoboGuys team, and we would love to introduce you to our project for the Design Expo, Cadre Arm. We are a team of aerospace engineering majors interested in lunar robotics. With the advancement of human space exploration efforts, we expect to see lunar habitation develop further from science fiction into reality. A possible avenue for this is the lava tube system under the moon's surface. Here, the ground provides protection from radiation and temperature fluctuation, and could be sealed off and pressurized, making it an attractive candidate for lunar habitation. To confirm these theories, the tubes must be explored, but their inaccessibility makes it dangerous to send manned missions down. To solve this problem, we propose the Cadre Arm project. A small rover equipped with sensors and a robotic arm could descend into the tubes, gather maps, environmental data, and samples, and return to the surface for further exploration. To accomplish this task, we designed and prototyped the RoboGuy. Let's get into the details. Beginning with the arm, an open-source 6-degree of freedom SO-101 arm that we controlled via ROS2 over a provided board. This arm was provided to us, and part of the challenge of the project was integrating it with a small rover in such a way that when it was fully extended, the rover didn't overbalance. That brings us to the chassis, designed specifically to accommodate the arm. With the U-shape, we push much of the weight towards the back without sacrificing much active area and create compartments for sample collection during operations. By our center of mass calculations, the rover will not tip even when the arm is fully extended. On to the sensor system. We used a 2D LiDAR as a placeholder for the more expensive 3D LiDAR that would eventually become our mapping tool. An IMU gives us data about the orientation of the rover in space, and the environmental sensors tell us about conditions while operating. With the sensors in place, we can consider the software system. The RoboGuy outputs data to a dashboard in Foxglove that works with ROS2. We run simulations in RViz and use a teleop drive terminal. In order to prevent one failure from affecting the entire robot, we've distributed communications and operations among 3 different boards, allowing us to control things separately and give the whole system more resiliency. The suspension system is a fairly standard rocker system that allows for passive incline and obstacle tolerance. It works by averaging the heights of the legs on uneven terrain and supporting the chassis. The wheels of the rover are designed with our environment in mind. The grousers provide purchase on loose basaltic rock that would be found on the moon. We implemented curved paddles to increase stiffness, and when supply issues caused the motors we received to be weaker than expected, we redesigned the wheels to be smaller in accommodation. Finally, the end effector of the rover was designed to serve 3 purposes by changing form. The claws can be actuated open and closed to grasp small items. They can be moved aside to use a shovel and closed entirely to collect samples or drill into the ground, as you can see. We implemented several smaller mechanisms to make this end effector possible. Once the entire system was designed and assembled, we were able to put everything together. Here, you can see the RoboGuy collecting a sample and depositing it in its compartment. The drivetrain test was also successful, though more so on concrete than on gravel. All in all, we successfully collected 2 samples and achieved wireless control for most of our components. The only concern was with our lower torque motors, we were unable to provide quite enough thrust for the wheels for comfortable navigation. In conclusion, we are very proud of this capstone project. We achieved many of our goals and learned a lot. In the future, we hope to strengthen this project by integrating stronger motors, making the arm fully wireless, transitioning to autonomous control, and using more advanced manufacturing methods to create a more robust prototype. This concludes our presentation on the Cadre Arm project. From all of the RoboGuys, thank you so much for watching.